Vector Podcast, Season 3. And as promised, I'm trying to shoot for 30-minute episodes. Let's see how I'm going to do on this one. I'm super excited to have Brandy, Vice President of Engineering at Rockset. I know you guys are building database. Hey, Luis, how are you doing?
I'm doing great. So far, so good. Thank you for having me today.
Oh, yeah, excited. Excited to learn about Rockset as well. But before that, it's a tradition. Could you please introduce yourself, a little bit about your background and how you got to your stage in your professional life?
Sure. So I've been at Rockset for two years and change, a little over 2 years. VP of engineering. Before that, I was at Facebook for 11 years. So I did roughly three things at Facebook, and it's funny because even the ones that feel least relevant have become more relevant recently. I did spam fighting infrastructure for my first bunch of time at Facebook, and that involved like two large systems. One was like a super real-time system, which turns into the real-time database we're going to talk about today, and the other was we did a lot of vector clustering. Like back, I was doing vectors, but way before they were cool. This time was like 2011, 2015 or so, and we used vectors a lot in spam fighting and image classification. And this is like even before like the deep learning took over the world. Like this is right before deep learning changed everything in this space. But we were using vectors a lot. We built some pretty powerful systems. I actually built like large scale vector clustering. I don't know, before it was cool. Now everyone's building large scale vector applications. Um, and then I worked on a lot of other stuff in my time at Facebook. So there was a lot of core C++, core libraries, a lot of infrastructure stuff. I worked on open source stuff called Folly and Thrift. So these are basically like core libraries that Facebook has released over the years. And the theme of all this is like highly scalable infra. And then I did some real time and some vector stuff back in the spam fighting days. It's not totally applicable necessarily to the modern world, but it's still a pretty interesting background and a very interesting confluence of things that have brought me to Rockset. So yeah, that's my life story roughly in a nutshell. There's more, but I think that will do for the intro.
Yeah, for sure. Fairly exciting, really exciting. I heard about Thrift, and I also remember like early on, many years ago, when some of you guys were on stage, from the engineering at Facebook, you would constantly, hint to the point that, yeah, we ran out of the capabilities of this database, so we needed to scale up, we needed to build a new one sometimes. And that was really, really interesting that it's constantly like, you always battle against too many images, too many videos, and so on and so forth.
Yeah, one of the things I always said was that like everything is broken at scale. Like there's this idea that sometimes you reach for the right tool for the job, but the reality is like when you push even the right tool to the limit, it will fall over and you'll find yourself doing things that other people, rebuilding something that other people take for granted. Like my favorite example of this is at Facebook, we had a team on my core C++ group that was working on malloc. Like who works on malloc? It turns out there are people that work at malloc.
Yeah.
Most of them work at like a place like Facebook or Google or places like that. But that's like the kind of thing where you can save a lot of money by making tiny improvements to malloc. And so it's worth doing.
It's amazing. I remember I did a bit of C++ as well. I guess like you could say 2.5 years. And at some point in the antivirus company here in Finland, I had to choose which malloc will it be, right? And I had to sort of discuss with my team, and I was like struck really, is that really the thing we need to discuss? And they said, yeah, actually, you won't believe because we are running on a mobile phone. Back then, it was this Microsoft's Windows Mobile, I guess it was called, right? So you had to be really careful with RAM.
Yeah. I mean, there's
Well,
only 3 or 4 mallocs in the world, so you might have chosen ours. Who knows?
amazing. All this says is that you've been really, really deep and low level. And so I think you doubled in coding, obviously, right?
Yeah, so I was a fairly technical. I've been a manager for a relatively long time. I don't know, 12 years or so, but I've always been a fairly technical manager in my path. And so, for example, like for years, I worked in like the core C++ libraries at Facebook, even while I was like a manager, even a director. Um, I was on the C++ standards committee for a while and doing things like that. Um, Sorry, I got paged. Everything's fine. So yeah, I've definitely worked in the code. I've tried to stay as hands-on as possible. In most recent years, it's become increasingly difficult. I don't know, it's sort of the dark side of management. You slowly slide into more managerial things. But I still try to stay about as hands-on as I possibly can.
Oh, tell me about that. I mean, I'm also on the product management side today, and previously a manager of people as well. And I'm like, am I sliding backwards? Well, do I need to code? Sometimes I do, but it's not on the same level as it used to be for sure. But it makes sense to stay on these topics. And then after all these years, you decided to move to Rockset. I've read a blog post that I think you've written for the company,
Yeah.
where you give the reasons why you did so, and you explain about the team strengths and so on and so forth. Some of them are from Facebook as well. Today Meta, right?
Yep.
Um, can you sort of repeat that story a little bit, like why you
Yeah.
moved from a big company, you could say, right, to a startup?
So the answer is, in short, is the people. The core group at Rockset is a bunch of. I shouldn't say the core group now. The core group now has grown a lot, but the original founding core was a bunch of extremely strong Facebook people that I knew from Facebook Infra. And so, you mentioned rebuilding databases, for example. Like two of the main people, probably three of the main people responsible for rebuilding databases at Facebook are at Rockset. So Druba, who's our CTO, was built RocksDB at Facebook, and that was part of replacing the storage plane of MySQL in a highly scalable way at Facebook. And then, of course, the graph database that powers literally all of Facebook. Like Facebook is a graph, and it is primarily powered by a graph database called Tau. Nathan and Venkat are two people who worked on that at extensively at like tech leads and founders in some sense of that project at Facebook. So this is like extremely pedigreed group. So to me, I don't care so much about that. They're also like genuinely amazing people to work with and work around. And so this is kind of this idea of like, hey, you want to join a startup with a bunch of the smartest people you've ever worked with and like try to do something. And worst case scenario, it all goes, kaput or whatever. But you worked with like some of the best people on a really interesting problem for a couple of years. And I was like, yeah, I'm in for that. There's a longer version of that story, but that is really the central reason of why I ended up switching.
Yeah, yeah. I mean, it sounds like a brilliant reason too. But I'm also interested. You said you've been using embeddings before, like at Facebook, vectors, and you said that prior to deep learning era. So can you explain a bit like how these vectors were
Yeah.
sort of created, if possible?
So there is some sensitivity here, but it's not maybe for the reason you think. It's not a trade sensitivity. This has to do with abuse use cases. What we were doing was image classification, uh, and and most of this is I'm not going to go into too much detail for maybe obvious reasons, but there are illegal images. There are images that you are not allowed to use or put up, and obviously what they don't want to do is hand all these companies like the images and say, if you see this illegal image, tell us. So oftentimes they give you hashes. But these aren't actual hashes. They are not a hash of the illegal image. They are a locality sensitive hash, and they're a vector. What they are is literally a vector. And Euclidean distance is the measurement so you basically have a classic vector search problem. You're given a pile of vectors. If there's a technology known as photodNA that you can look up. It's not, as far as I know, it's not like an open standard. So it's not actually in the public domain what it actually is, but it's effectively a mechanism for turning images into vectors that's used as this hashing mechanism. And so Facebook built a bunch of infrastructure to flag hashes that came through for reasons that are not fun to talk about. Let's put it that way. Like there's like, again, I don't want to get into it.
Yeah, yeah,
It's awful, right? But
yeah,
at the end of the day, like you have vectors flowing into the system, and what you're doing every single upload is doing essentially a vector search. You're saying like, hey, given this corpus of vectors, does this vector that's coming in
yeah,
match any of these?
yeah,
That was the basic core of the system. But once you have these vectors, you can start to do other abuse things. So for example, you can start clustering vectors. You can build vector clusters. And that way you can find like neighborhoods of images, like similar images. Now similar means something quite different.
Hmm.
Because these were not like semantic similarity. So this is not like what you would get from an embedding today from like, say, any of the modern
Bird, yeah,
imaging.
bird clip,
Yeah.
whatever. Yeah.
These were much more like textual. I mean texture.
Hmm.
So for people familiar with like image processing techniques, these are vectors based on things like local pixel gradients or wavelet transforms, things like that.
Yeah.
So when we say images were similar, we mean to things like, like rebalancing the white scale or changing the hue and saturation, like those kinds of image manipulation or re-encoding it, right? From a different
Hmm.
JPEG to a different JPEG encoding. Like it was tolerant to that kind of manipulation, not like it wasn't like finding images of elephants. Like that's not what it was doing.
Yeah, yeah, yeah. I remember I took a course. Actually, I studied a master degree in Finland here, uh, dedicated to data security, and one of the courses was about, how you can tamper with images that had watermarks, right? So like,
Right.
yeah, and then how do you make that watermark resilient to any tampering that might happen on the image level, right? On any of the bands and stuff, and as you explained, hues and stuff.
Yep.
So that's basically the digital image processing is the word to Google if someone wants to, and then it's like a big, big topic. Um, but what struck me in what you explained is that every image upload had to go through that process, which means it had to be super scalable, and also your database of vectors would be ever growing all the time as the image passes through, or doesn't. You would need to add it somewhere to your vector space,
So
right?
in this case, no. This is the one advantage we had because we only care about matches to a specific relatively small set.
Oh, I see, I see. So it's like a set that shouldn't grow ideally, right?
Yeah, or grows
Those the
very,
images
very
to be
nominally.
card. I see.
Yeah.
Wow.
And so it's funny because that's a big difference. That makes it easy in that era. Today you'd have to bust out all the ANN stuff and maybe stuff we'll get into to
Yeah.
really be able to do a really much more scalable vector search. So this was really more about evaluating a relatively fixed set of vectors. So you could hyper optimize how that was organized in like but evaluating it at an insane scale. So the update problem wasn't very hard, but the evaluation problem was like it needed to be extremely high scale.
Yeah, a bunch of questions in my mind, but let's move on to
Sure.
Rockset. Tell me more about the what part, what
Yeah.
it is as the product, and then slowly let's go deeper into the technology side.
Yeah. So my standard statement of what Rockset is Rockset is a search and analytics database built for the cloud. And that's a bunch of I forgot one. It's a real-time search and analytics database for the cloud. Now that's a bunch of little buzzwords that it's very easy to get lost in the kind of marketing feel of that. But each of those words does like non-trivial amounts of work in what it is I'm really trying to build here. So first of all, it's a search and analytics database. So here what we mean is like an OLAP style analytics database is like it's like that's where we're starting. We want to run an analytics type queries. And this, I won't get into all of this, but this is like separate from your OLTP style databases. So this is not MySQL, not a large transactional thing. It is an OLAP style database. And search and analytics is a very interesting pairing in this world because systems like Elasticsearch are very search-oriented systems like Rockset are very analytic styles, but these are actually not that different architecturally. They're very the way you use them may feel different. The primitives you're using feel different, but all that sits fairly shallowly in the technology. The underlying architecture of these systems ends up looking quite similar. So search and analytics actually go together quite nicely from like I can do both. Maybe I don't do both well, but that will mostly exist at the top, not on the infrastructure. It's in the cloud, so the whole system is built to be elastic from the beginning. So if you send me twice as much data, I can scale you out in a way that like it just works. You don't have to worry. You're not re-provisioning more machines to double your cluster size or anything like that. And then real time. So our focus has always been real time, which is to say specifically, most people when they think of real time, they want their queries to be fast, but the real heart of real time is ingest latency. So if you send me new data, how quickly does that data get manifested in the queries? If it's tomorrow, if it shows up in tomorrow's queries, that's not a real time system. And there's a lot of systems like this, these very big batch style, like mega exabyte type of like Hadoop clusters that you You can query yesterday's data, right? And get like genuinely enormous amounts of data. That is not Rockset, like as that's not Rockset's problem. But for us, it's like, hey, if you want like last minute's data and it's ideally several zeros smaller of a working set, then that's where Rockset is meant to work really well. And so this is like the heart of this is what we've set out to build at a high level. And I I don't know if you want to. Do you want me to keep going? I don't know. I feel like I've already said too much. I'm
No,
happy to dig
no,
into
no.
more
I
details.
want, no, it's amazing. It's a good start. I wanted to stay a little bit on the product side. If you go now and flip over to the use cases for the
Sure.
moment. So what are the typical use cases and sort of can you zoom out as much as possible, maybe even giving, even if hypothetical, it's fine, but examples of products that use your product.
Yeah, so we have a bunch of customers in a bunch of different domains, and it's we can even go. So one way to think about this is just like who's using it and why, like what domains are they using it in? And so for example, we have a bunch of gaming customers. So this is like there's real-time events occurring in games. Imagine an online game of some sort. And uh they're collating that information constantly and having it be real uptime, say leaderboards or things like that are happening. There's several actually like logistics and supply chain type people using it. So like, where is my package right now? Or where is the boat in the ocean? Like these kinds of queries are like very commonly done, like where they're basically tracking their entire supply chain, trying to find shortages and what's going to create problems down the line in like logistic type settings. There's a lot of fintech. There's a lot of financial firms use it, a lot of fraud detection. So again, fraud and spam, these are very real-time problems. You can't like detect yesterday's spam or fraud. That's like really harmful. You need to know now, right? Um, and then a lot of like recommendation and like product experience. So anytime that like you want to power a user facing experience, you almost always need that to be real time. So example I like to use is there's a place called Whatnot. If you can go to whatnot.com if you've never heard
Mhm.
of it. Whatnot is basically a streaming site for buying and selling. So it's sort of eBay meets Twitch kind of is the easiest way I could describe it. But what's really cool about that is you have a recommendation problem. Like I want to buy something, there are people selling it. So I it's really in the site's interest and my interest for you to show me like you might want to check these things out. That's like a recommendation problem, but it's like really real time, right? It has to match me to online sellers at any given moment. And so it's a recommendation system that has to get built, needs decent amount of it needs high scale, and it also needs to be real time. It needs to use a lot of real time data. So these are all use cases for Rockset. Every one of these is real customers
Yeah.
using Rockset to do something.
Yeah, for sure. Now I want to go back to jump back to tech side. So
Sure.
Rockset, and inside it, are you using RocksDB or something else?
So
Okay.
okay. Are we using RocksDB? So first of all, do we know what RocksDB is? Just so everyone's on the same page. RocksDB is an engine that was built by Drew at Facebook. And I shouldn't say by Drew, but by a team that Drew was a part of. Like he was one of the original founders of that team. There's certainly a lot of people involved in RocksDB. It's a key value store, right? That's built sort of to scale very well and sort of do log structured merge over time. Rockset absolutely uses RocksDB as its storage plane. And so there's a lot of Rockset built on top of RocksDB. So Rockset is not RocksDB as a service. That is not what Rockset is. We do use it as the storage plane of Rockset, and we do take heavy advantage of, again, to get into the technical weeds a little bit, like log structured merges to keep our indexes sort of up to date continuously. And that is a big part of like the real timeness of Rockset, like being able to update the index continuously and having this like heavyweight infrastructure to merge these indexes in the kind of the append only log structured way that you do. In the LSM world is part of the secret sauce. I mean, it's not that secret, but it's part of the secret sauce of Rockset.
Yeah, for sure. But then also all these things like vector search, storing the embeddings, is that also happening outside of RocksDB, basically in the layer you explained?
So hold on, you asked about vector. What were the things? Oh, embeddings
Embeddings and
and
vector search itself.
and the sort of ANN indexes,
Yeah,
presumably.
yeah,
Yeah. So the ANN index. So we've extended RocksDB a little bit to kind of have this notion of a blob of memory that you attach to a particular thing. It's what's going to be the A and N index. And then you can build custom operators to merge them, for example. And so that we do essentially shove the A and N index into this. And so it gets into RocksDB. RocksDB doesn't know about A and N indexes. It just knows there's a blob of memory that it has to log structured merge down the road. As far as embeddings, for us, that's just arrays. Like, so for us, an embedding is just a vector. And for us, a vector is just an array. There's no real difference in the way these things are stored. And those are stored in RocksDB.
Yeah, got it. And so, and basically, what other AI capabilities does Rockset offer? You know, basically everything. What's the secret sauce of that thing? More like user facing, right? But still.
So I have there's a few things to talk about here when we talk about secret sauce. So one thing we skipped over about, one thing that was worth touching on in terms of Rockset's like core architecture is Rockset has two things that you hope every database has, but not every database has. One is we have disaggregated storage, like fully disaggregated storage. So if you double your storage, you can double your storage, you can double your compute, you can do either. You don't have to do both, right? There's compute optimized machines and storage optimized machines, and you can add to either group independently. Mm-hmm. We also have compute and compute isolation. So you can set aside a set of machines, for example, just to do ingest, and a different set of machines just to do queries. And they both operate on the same backend, for example. You can go farther than that. You can have like different groups of machines for different sets of queries, or by tenant or whatever. You can go wild with this idea, isolating compute from each other, right? Mm-hmm. Once you have disaggregated storage, this is an idea you can do. This is already really powerful for AI use cases, like in a way you don't necessarily appreciate, because what it means is I have a way to do my index rebuilds, which are expensive in a vector world, away from the machines handling queries. Like what's not going to happen is the database is going to bog itself down doing A and N index updates of some sort while queries are trying to be served, and you're going to get timeouts and these other things. So being able to actually separate out compute is very powerful in these AI settings. Again, another example, no one's done this like in total anger yet, but it's going to come, which is like hey, I have a god-awful amount of vectors. I want to update them to the next generation of the new OpenAI model has come out. I want to rerun the entire data set. We can do that in this kind of like off on the side fashion in a way that just redoes it all in place without affecting the running application, as an example. So that's one like kind of very architectural it's a very database type of a feature that you will miss it if you don't have it when the day comes. Moving up to kind of more AI level things. The other thing that we have is like, we have a huge pile of infrastructure of like doing SQL and relational queries, right? In this system that's separate from the vector stuff. So when the vector stuff gets mixed with that stuff, the things get very powerful and very magical. And so this gets you into, it's funny because database people talk a certain way and AI people talk a certain way. And a lot of times they're actually saying the same thing, but they use none of the same words. And so they don't know they're talking about the same thing. But as an example, like, so in an AI context, things like metadata filtering or hybrid search, these are all things Rockset does out of the box. Like metadata filtering in an AI context or a vector context, that's just like the where clause of a SQL query. Like that's all that is, like where X is greater than this and then time is greater than that. Like, so for us, that's all done. Like metadata filtering is easy. That's not a hard problem at all. All I have to do is, I have this super powerful query language. I have a query optimizer. All I have to do is kind of merge that with the ANN kind of vector search, and I get like metadata filtering is like that's not a hard problem for us to solve, like it would be for others to solve. And so I do think we really shine in situations where A, you care about real-time ingest. B, you care about any kind of hybrid or metadata filtering. Rockset's really good as well for kind of raw vector power, but I wouldn't say we're like the best database in the world for like, I don't know. I view it more like we're kind of going where our customers are taking us. Like if the customers came to me and was like, hey, if I could have 10 times more vectors and like 4% more precision and recall, if you implemented this slightly better algorithm with these parameters, we would do it. But almost always it's like we want that, like hybrid search seems to be the king. Like it's merging these things. And that's where like a lot of our effort has gone, is into making the hybrid search story, like making these two worlds work together like fairly seamlessly. Like be able to say like, show me the closest 10 vectors that were updated in the last 10 minutes. Like that kind of query is really powerful. And that's kind of what we've been focused on in terms of
But,
AI.
but I guess the timestamp example you gave, it's also like metadata check, right? It's kind of like where clause where you say between A and B
Yeah.
timestamps. But like
Yes.
hybrid search, at least the way I'm hearing people do this is that, let's say, take the search domains example. You might have a keyword search, right? Which is your sparse index, and then you have your dense index. Vector search, and you want to combine the two in some way. For example, you could say, I still trust keyword search, so let's give it 75% of
Yep.
weight, and then
Yep.
25% goes to vector. And then you combine them, interleave them in some merging strategy, and then you return back to the user. Is this how you see hybrid search, or do you see that
So,
differently?
so I have a whole rant here. You might have, yes, you've unlocked my rant here. So let's go, let's do it. So hybrid search is one of these very overloaded terms, exactly as you have kind of, this is kind of sometimes what people mean. Sometimes people do, they smuggle metadata filtering as a hybrid search. Strictly speaking, under my definition, metadata filtering is a kind of hybrid search. It just sort of has extreme weights, right? Like it's weight 1 if it matches and 0 if it doesn't. And so it's kind of like a weighted hybrid search. You can also do this kind of linear combination hybrid search, right? Like I have a BM25 keyword type a ranker, which by the way, Rockset can do, like Rockset has this. Rockset, you can do this order by keyword ranking, limit 10. Like you could write that. And then you can also then do the vector limit 10, like show me the 10 closest vectors. There's nothing stopping you from saying, or, order by 0.25 of that plus 0.75 of that, for example, in your example. So that kind of linear combination hybrid search is doable. Like that's how you could do Rockset. Sorry, that's how you can do that kind of hybrid search on Rockset today. Now people do slightly more advanced things than this, by the way. There are like you can go beyond that in hybrid search and get into things like by encoding and cross encoding, where you really do try to take the expanded vector space and treat it non-linearly, so it's no longer a linear combination of the two halves. And this is something we are actively looking at. I don't think it's hard to add. Like it's easy extension onto the current system, but it's more of like a science question. Like it's more of like, if you tell me what to add, I'll add it. Sure, that's easy. But it's like, what do we add? Like, what's the right crossing code? I don't know. That's a much harder problem. That's like much more of a scientific question in terms of like, do I need to train an encoder for your particular use case? Is there such a thing as a good off the shelf one, right? So that's kind of where we're at with this. But in terms of adding that functionality, that is like an active. This is the frontier right now for us.
Oh, yeah.
That's for those people that they're trying to go beyond the kind of bilinear
Yeah.
weighting.
Yeah. Yeah, another thing, yeah, bilinear is it's amazing. Maybe you can share some resources as well for me and the audience to read. But also I thought, when hybrid search sort of topic emerged, right, in the vector database world, BB8, Pinecone, Milvus, Quadrant, and so on. I think one thing that was overlooked, and I really wanted to tap into that at some point, is to learn the alpha, right? Because it's not given. Like, how should you if you go with linear combination, what should be the alpha for your data? But yeah.
Yeah, it's fun. Yeah, this is what the search community has been doing things like this for a long time. Like search people are quite familiar with this idea of, I have a semantic search system, I have a keyword ranking system, I have an alpha, and I learn that alpha and I inject it into my system. And then they've even gone farther. Like search has this whole like wand idea. I don't know if people are familiar with. So again, we have all these communities colliding. Weekend, exactly,
Yeah.
right.
Joe
And
Bergom, listening to this podcast, will probably say, yeah, I know what you're talking about.
yeah. So it's funny because like the vector community is sort of like, I mean, it's not rehashing, it's not relearning, because it's got this new thing, this A&N thing. So it's got to like drag A&N through the search history of like things, these other kinds of things. So yes, so learning the AND parameter. This is not a particularly hard thing to do using Rockset, but it's not a thing we don't help you. Like I don't have a button you push to automatically learn your alpha. Like you can send me whatever query you want. It can have whatever alpha in it you want. You can build whatever system. You can query us arbitrarily to generate an alpha however you'd like, and then send me the queries with the alpha you've generated. But that's roughly how that's going to look today for us.
Yeah. Do you think at all, maybe peeking a little bit into the future and sort of aspiration, do you think at all that the industry you are in one day will end up suggesting these values to their users? You know, learning from the data and sort of maybe even like, you know, looking at how things behave, you know, in
Yeah.
production. What do people click? Although, yeah, there is a risk of going too much into the application logic, which you probably do not want to do. But I
I don't
mean,
know. I My view is kind of like, so once upon a time I had a similar feeling. This reminds me of a similar discussion that didn't happen that long ago, which was like around feature stores. Like database people looked at feature stores and were like, what do you need a feature store for? Like you just use a database, store it for features. And the reality is most feature stores, that's what they are. They are databases that on top of them put a lot of things to help manage as a first class citizen the lifetime of a feature. Like orchestration platforms, like Tecton and these like ML orchestration systems. That's what you're, I think no matter what, there will always be a database in there. And something like Rockset will be in there. And the question of whether or not Rockset, the company, is like a larger piece of software that has Rockset, the database, and some orchestration layers above it to help you do these kinds of things, that's a harder question. I think that if you ask me to make a prediction about where things are going, my guess is that for the foreseeable future, hybrid search is king of some kind. So very few problems will be purely vector search. That's my guess. Almost all will be greatly benefited by some form of hybridization, even if it's just metadata filtering. And then that means that the more advanced search techniques that will slowly migrate over, which means things like alpha learning and weak and all these other kinds of higher level two-stage retrieval type ideas that come from the search world, I do think will come over and more influence the vector search world, because the vector search ultimately is a form of search. So it shouldn't be surprising that most of these same ideas are still apply.
yeah, yeah, for sure. I mean, there is this extreme example from Mark Cuban, the episode on Lex Friedman podcast that I just finished listening to. He says that probably in the future, all of us will have their own LLMs trained for whatever reason. You know, for example, you want to do stock trading, and so you start, you know, training your model maybe on specific subset of stocks or whatever, and then it'll help you. It will augment you as a
Yeah.
as an entity,
Yeah,
and
I would
that's
love
yeah.
I would love for a chat GPT that could like make an email, sketch me a skeleton email in my voice. Like the chat GPT voice. If I say, hey, write me an email to say this to somebody, it's not my voice, right? I don't know, it's a little too corporate. My voice is a little bit more. Yeah. So it'd be cool to have it like learn my voice and be able to, write me a skeleton that of something that was like sounded like me. That would be awesome. I'm there for that.
Yeah, yeah. What I would like is that some model or whatever it is would remind me that I forgot to drink water, you know, something like that. So it learns my habits and it knows that it's bad for my health. You know, remember to do this, remember to stand up, remember to walk, things like this, you know.
I drank some water in
Yeah,
your honor.
that's good. Thank
Everyone
you.
drinks some water.
Yes. Yeah, please do because it's very healthy. You need to drink, I guess, 2 liters a day, whatever. Some people do forget this and then they say, have you know, I have to take painkillers or whatever. No, you don't. Just drink water. Um, but so what else do you want to share about Rockset, you know, as an offering, as a AI enabler? You know, maybe do you guys plan to support RAG, or do you think RAG is sort of like client side, you know, thing as well that people can do, you know, using your tech, things like that?
No, no, we actually have a bunch of RAG type style use cases on Rockset today, and I do think Rockset naturally supports RAG. It's interesting. So, like, I guess one of my kind of open questions is pure RAG, and I'm making up a term here, but it is actually one of the very few like almost perfect vector use cases in its pure vector search. But I'm actually not convinced, because even most of the people that we know that are doing like RAG style things are also doing some amount of boosting and or metadata filtering to like further augment, like hybrid augmented the retrieval that augments the generation. And so for example, like, hey, if the user asks about a certain thing, when you search for blurbs to augment the generation, boost the more recent ones, kind of a thing. Like there's this kind of thing that gets injected into these systems. Yeah, so you can build this with Rockset today, and I'm quite keen on these kinds of use cases. I would say that like looking forward, I am quite interested in this kind of emerging dynamic of like where the real value is from here. There's sort of like at least 3 dimensions things could go. One is like better and better ANN algorithms that squeeze more performance and more scale and more whatever at recall out of everything, out of every byte of RAM and so forth and so on. Another direction is incrementability. So there's a lot of these like really advanced, really strong systems, ANN indexes are not updatable easily. So the sort of updatability destroys a lot of what you just worked really hard to build, or you spend way too much CPU to do it. So which is better? Like which in real life, which of the would I rather it update twice as fast or twice as painlessly, or would I rather get 3.5% more, on my precision and recall? And then the third dimension is how do these things integrate with other indexes, right? So certain ANN indexes are much better at doing metadata filter at scale than other ones are. And so, if there's more value in that than the 3% I got over here, so it's not altogether clear. We are pretty heavily betting on I shouldn't say we're betting on it. Like right now, we got the hybrid stuff relatively easily. So that's the thing that we've been building heavily, because all the hybridization has been, and the incrementability, because that's core. Like, so for us, the incrementability is like you have to have that. I can't use an ANN index that requires like overnight training. Like that's not a thing that doesn't work with Rockset, because we're trying to be real time. And then I guess there's like one fourth dimension that could blow all of this up, which is that somehow the vectors get so good that none of the rest of this matters. Like maybe there is no RAG, maybe there is no, like maybe the vector is just good enough. Maybe the machine is smart enough that we won't need any of the rest of this. We don't need any hybrids. I think that's unlikely in the short and medium term, but who knows in the long
Yeah,
term.
that's probably requires some kind of singularity
Yes.
with this jump, right? Because then it
Yes.
means that you do not need foundational models from Meta or whoever, right? You could train it from scratch. And if you can do it within a couple minutes, then why would you bother taking those models, right? That's very
I agree.
interesting.
It's that's why I said there's 3, and then I threw the fourth one in, because it's it's not impossible, but I think it's not likely, not anytime soon.
Exactly. I mean, it's probably if this is about to happen, then probably we would already see the like the signals of that. But today, still, you can see how these giants keep training the models, and they keep open sourcing, sometimes in quotes, sometimes for real. But yeah, it's another topic to cover. I have a very practical question as well. So, for example, if I do have a model, and that model could be from Hugging Face, for example, so it's not mine. Um, how do I bring the embeddings to Rockset? Can I leverage the Rockset's infrastructure to compute the embeddings themselves?
So the answer in short is no today. And it is on my list, super high on my list. So if there was a customer who came to me tomorrow and was like, hey, I want to run this model using your infrastructure over my data, I would probably find a way to make that work for them, like an existing customer. Like I would like, because that's a feature I want to build. I'm like waiting for the excuse to build that. The problem for me is it's just really hard to build generally. Like if it was like call this API or support these exact kind of models, it's not so hard. But to do it in general without having like a specific customer demand, it's a little bit trickier. So we've been kind of waiting for that to take a little bit more shape. But we have the pieces in place. Like it's not hard for me to spin up a bunch of machines that run on your data and write to your database. It's the actual like last mile of wire of like, what code do I run? How do I secure that code? Like that kind of stuff. That's like what's missing from us. So today you have to give me the embeddings. You're gonna have to run them and put them into Rockset.
Mhm.
But this is at the top of my list of sort of features I want to build.
Yeah,
Just
yeah,
waiting for
no,
the right
I mean,
moment.
it just sounds, and by the way, if you take databases today, probably you could divide them into two groups, using this dimension specifically, whether or not you can compute embeddings inside. And sometimes you do not want that because you want to like fine tune the model. And obviously the database wouldn't have access to it unless there is a very easy way to plug it in, which I haven't seen, by the way. Probably I'm missing
Yeah,
something, but I haven't seen it.
I see.
And everyone today has some sort of vector support, both the traditional databases as well as this new breed of vector databases. But yeah, that's interesting. That's interesting that you guys are looking in that direction. Um, what else? Like if someone wants in the audience wants to try Rockset today, you know, do they need to pay right away, or can they have some free tier to play
Oh,
around?
there's free tiers.
Can
Yeah, so
this?
you can play around. You can play around for free in Rockset. And uh if anybody is like super interested and they have something interesting, then they can always email us too.
Oh yeah,
We will try to find a way to make that stuff work as much as possible. But yes, there is a free tier. You can go back around with it.
yeah.
Um, and it is managed. So the one thing you have to understand about Rockset is it's a managed service, right? So you're not going to download it and run it or whatever. That's not the way it works.
No, and by the way, that's exactly the advantage for businesses, right? And that's why
Yeah,
we do have different business models, you know, because in the end of the day, you're not doing this only for fun. You really need to earn money too for the company to grow and build more things for your users. And so that's absolutely legit approach. Not everything needs to be open source. You chose it that way, but it's great that you have free tier, and we can also link it in the show notes.
sure.
What are you looking at? Do you need some? You said you have already so many clients in different niches, different verticals. What else would you benefit from by sharing Rockset into a wider community? Through these podcasts.
So there's a lot of ways to answer this question, but this is the vector group, right? So selfishly, I kind of already hinted at this, is I'm trying to get a clearer sense by where the value is going to come from and for vectors in the short and medium term for people. Like there's a lot of people out there, and we saw this. There's a million people trying to, oh my God, vectors are happening. How do I plug this into my business? Like, can I use this? And we've seen a bunch of interesting, super novel use cases, like the things you would not expect. Like, there's an insurance company that wants to like scan internal documents and they want to do search. They want to do like internal search, semantic search. Um, and so for me, my most selfish interest here is to really get a clear picture of like which of these like little subdomains is actually really providing like real value. Like what is really like taking off. Sometimes it's hard to tell like who's just messing around because everyone's messing around. Literally everyone is messing around. And who is like actually latched onto something that's got some real legs. And every time we find a customer that's got like real legs, we dig in and we're like all in. We're like, all right, how can we help you? Like let's again, like the I'm waiting for one of these people to come back and be like, can we retrain our embeddings? I'm like, all right, yeah, let's go build it. Right. So that's kind of yeah, I want people to keep messing around with this stuff. I want to figure like all of us messing around with it is going to find where it gets traction, like where we can get our hooks in and where things start to really make progress. And then I just want to hear from those people. Like I want to know what you need. Every time we talk to someone, it's something new and surprising. Right.
Mm-hmm.
And
Mm-hmm.
that's kind of when the real world intersects with all this, like, in my head, it's all ANN indexes and graph theory or whatever. But when the real world intersects, it's always something like simple that you need that would make your life a lot easier. And that's the kind of stuff that I'm eager to hear.
Yeah, I think I could share quickly without saying what we're building. One member of my team said, "Hey, we're POCing one search engine today, which also has, beyond the sparse index, also has vector search support." And so he was saying, "Okay, they're using HNSW algorithm, but I cannot tweak the M parameter, and I forgot what was the second parameter, And look, because I cannot do that, recall is really below what it needs to be. It just doesn't work. And then he went online. It's an open source database. He typed, the issue on GitHub, and they realized, oh, we missed a really important thing. So they quickly exposed the parameters, and so he now can tune them, right?
Yeah.
So
So yeah, I mean, the tuning of the index is another, this is a good one, right? So a lot of these systems have like a tiered, there's like a coarse grain and a fine grain. So you have HNSW over IVF or HSW over, or IVF over IVF. And then each of these has parameters. And so you get these like massive config strings that say how these are built. And we expose this, so you can do all this stuff. But in real life, if you're building, like what number do you even pick? Like, how do you know? I don't know. That person must have gone through a lot to decide they needed to change that number, because it's not obvious. It's not like, oh yeah, it's not like you look at the data and you're like 16's wrong. Like the infrastructure to like optimize this system is not trivial. And then even if you do optimize it, you have to rerun everything. You have to rebuild that index, right? Once you've kind of trained it, so to speak. So yeah, I think that's a huge area where our infrastructure is not helpful at the moment.
yeah, but I'm sure you will learn. I'm in general excited. Like Luis, look, you have so much information that I think we should record another episode as well down the road as you
Okay.
guys are progressing on the database, and you add all these interesting, tweaks that knobs to the database as well. But I'm also super excited about the direction, because basically you offer, like, if you take pure vector databases, they do not implement SQL support, right?
Right.
They, like, the purpose of the existence is something else, right? They've been designed uh, to have vectors as the first class citizens, and so they they make it super easy to plug in a model or actually have the model, almost pulled from Hugging Face or some other model storage model hub. Uh, but then when you want to do some facets or whatever you want to call them, aggregations, right? That's not as easy. Depends on the database probably as well, but I've seen some. I don't want to name them, but in any case, they know it's a weak point, and it's probably because they do not want to serve that segment of the market. Maybe they
I
do
just think it's hard.
eventually, right? But it's also hard. Yeah, exactly.
Yeah, I mean, I think that the really good vector databases who succeed will slowly turn into databases,
Yeah,
and the databases will turn in, like, these things are merging. They're just coming at
yeah.
each other from different directions. Like if you're at a vector database, if you're building a vector database and you're looking at your metadata filtering support, you're like, I can't make this more powerful without just reinventing SQL. Like at some point, I'm going to have to just build SQL. And so one day we'll bite the bullet and I mean, maybe not SQL, but something, SQL complete, if you will, right? Because you just need all that stuff. And then pretty soon you get into the problem of like, hey, my metadata filter is the slow part of my thing. So now what? Like, oh, now I'm doing query optimization, like SQL query optimization. Like now I'm building query optimizers, like metadata filter optimizers. And so we have all that. Like we brought all that to the party, right? Like I have a cost-based optimizer for my SQL query. So if your metadata filter does crazy stuff, I can like do, all kinds of SQL magic to optimize this query. But on the flip side, like, yeah, like, so everybody, I, I think the good systems need all this stuff. So it's just, we took a hard problem. We took two hard
Mhm.
problems and we say, congratulations, this is now one hard problem. And it's like, okay, well, okay, it's a big, hard problem.
Yeah, I love how you model it, that these databases and non-databases sort of will converge eventually. Even though everyone, I think, at this point calls themselves a database, with
Yeah.
probably minor exceptions, but still, you are spot on whether or not, first of all, what is a database, right? And then whether or not you have all these features that need to be supported, and also, like, really importantly, the world is used to having SQL databases, right? So like if you sort of, I don't have a better analogy, but basically if you develop something and you say it can run but cannot walk, and you're like, oh, okay, but sometimes you
Yep.
need to walk, right? That's amazing. Before we close, I really like to ask this question. Some people find it a little awkward to answer, but I
Okay.
do feel it's important. It's a little bit philosophical, and I ask, what
All right.
drives you? It used to be why you do this, But basically, when you wake up, you are driven to continue. But what's inside that feeling? You've been through it, right? You've been doing this for so many years, also at Facebook, at scale, but you want to continue to do that.
So I am the way I think about this is there's like a shiny problem at the heart of all of this that I love. And if you let me, I will sit there and like I will be happy if like I just come into work every day and like look through the core dumps and fix bugs, anything that's crashing, then look through the profiles and like optimize code. And I can just do this. This just makes me happy. And so like building like reliable, scalable systems make me happy. So there's like this shiny problem in the middle of all this, and it's like the common thread through everything that I could just do and be happy. And it's rewarded and rewarding, right? And so that like the basis of like it's really easy to like this stuff. So then obviously you have to extend upon that, like the way that you get driven beyond the shiny thing. Because I could go do that for like Minecraft mods. I don't have to do that for databases. Is like in some larger mission that like you feel connected to. So for me, um, the the mission here was a little bit twofold. The people was actually kind of the original driving force. Like this is the people. I don't care what we're doing. Like let's go do it. Like us as a group. That's going to be fun. But then the whole AI thing. I mean, look, we can get philosophical. You want to get philosophical? Do it real quick. There's like 2 or 3 nominations for technologies that will change the 21st century. Like, and you got to work pretty hard to not put AI at the top of that list. Maybe there's some other ones you could argue, like maybe nuclear fusion is a 21st century revolution. Maybe gene editing. Like, I don't know. You could come up with something, but like chances are that AI is gonna be like a defining 21st century technology. So you're gonna let me play with my shiny toys in that? Yeah, that's okay. I'm out of bed now, right? I'll get out of bed. I'll come get out of bed and let's go build something. So I think that's my answer to your question.
Amazing. And I think you've done it and unprompted really. Like I saw passion, knowledge, serendipity, and openness. So I'm really excited to see what you guys gonna build. Thank you
Yep.
so much for joining me today to discuss. Yes, we didn't go to the A&M tuning this algo and this is how the algorithm goes, but hey, I really enjoyed the product level. This is on the money, as some
Yeah.
manager in my company says. Uh, yeah, fantastic. Thank you so much, Louis. Enjoy your day and let's talk soon.
Awesome. Thank you for having me. And yeah, happy to chat again.
All right, cheers. Bye
Bye
bye.
bye.